And your 6-7 radioactive decay half-life problems. All right, so what am I going to do here? I really don't want to do number one, so let's do number two. Medicine has a half-life of 6 hours. Patient is given 600 milligrams at noon. At what time do they have 100 milligrams left in their bloodstream? So we'll just plug into the half-life formula because, the key word there is half-life. Half-life formula is principal times 1/2 to the T, sitting pretty over HL, half-life. All right, so we're given 600. That would be our principal. We have 100 at noon. And that's the goal. What time is it going to be when they have 100 left? I don't know the time, but I know the half-life is 6 hours. Let's do this one. We're still going to do isolation. Then we're going to LN both sides. It's a different technique. 100 over 600 would be a 6. Don't use the decimal because you'll round. And the 600s cancel out, so we have 1/2 to the T over 6. Now what I'm going to do here is I'm going to LN both sides. You might like this, you might not. It saves you from having to know change of base. That's what it saves you. You can also log both sides. Anyways, the natural log of a 1/6 would be equal to the natural log of 1/2 to the T over 6. Now, we know that exponents go out front, okay? So my next line would look like the natural log of a 1/6 equal to T over 6 times the natural log of 1/2. Now, some kids do have an issue with the ln of both sides because they really, really struggle with what's going on here. The opposite of division is multiplication, so we're going to 6 both sides. 6 natural logs of a 6 is equal to T natural logs of 1/2. And now the opposite of multiplication is division, so we divide by the natural log of 1/2. And that's my answer, right there. It's perfect, because I counteracted every operation. And then I can go push buttons in a TI-84 and see what it is. So we got 6 natural logs of a 1/6. I'm going to divide that by the natural log of 1/2. And it takes about 15.5 hours, right? Roughly 15.5 hours. So if this was at noon, what time is it? It's 3:30 a.m., right? This was at noon, which is 12 p.m. Isn't it a shame that I have to talk like this to juniors? But so many kids be like, I don't know, I can't do that. I don't know. How many hours in a day, bro? Anyways, if you add 15, I believe you would get 3:30 a.m. And that's when the nurse will come wake you up and give you more drugs. There you go. There's your nursing problem. Let's see. Let's look at 5. The half-life of weapon-grade plutonium. Plutonium-239 is 24,100 years. Find the yearly decay rate. This is actually straight out of your notes, believe it or not. I mean, you can go look at your notes and get this problem. You can. I swear you can. But you won't, even though I said it. But anyways, let's plug in. The amount of time passes the principal times 1/2 to the T over 24,000. You know what? I'm not going to do it. It's literally in your notes. Let's do something else. This one was for a student I had 2 years ago. During the Chernobyl accident, a radioactive element, cesium-137, was released. Cesium-137 has a half-life of 30.05 years. The contamination was approximately 1 milligram per square kilometer. That is the equivalent of 8,690 picocuries, which is a measure of radiation per square kilometer. The safe level for humans is 200 picocuries. When will cesium-137 no longer be a worry in Chernobyl? So even after this is gone, there's still some bad stuff floating around, by the way. So this would be your goal. That's the amount after time passes. The initial contamination was 8,690. And of course, we have half-life mentioned. So T over 30.05. And the goal here is to figure out how long it takes to get down to a safe level of background radiation for that. So let's just do some math. We're going to divide out that 8,690. And I'm pretty tired, so I'm not going to do that in my head. Let's see what that fraction reduces to. (2869) is 1/2 to the t over 30.05. Now, on the previous one, I did an LN technique. So let's just make this thing a straight up log, because you may or may not have more success with that. I do not honestly know. I really don't. There are some positive aspects of both techniques. We have a base, we have an exponent, we have an argument. A log whose base is 1/2 and whose argument is 2869 would be equal to t over 30.5. This makes sense for some kids who struggle with the end of the LN technique where you got to do multiple steps. Of course, you got no change of base here. This is the natural log of 2869 sitting over the natural log of 1/2. And what we're going to do is we're going to multiply both sides by 30.5. So we'll just put that right there. That's my time. So let's see how long it takes for Chernobyl to be safe from this particular element. There is bad stuff still there. And that was sitting pretty over the natural log of 1/2. So 164 years. We'll just say 164 years. We want to be on the safe side here. We don't want people moving back immediately. 164 years. And again, I ain't going to do a whole bunch of these. I just don't have the time tonight. I don't feel that good this morning. Let's see that one. I'll leave that one for you. That's why I went away too. I'll leave that one for you too. I need to do this. Use the graph below for 10 through 14, which is obviously labeled 18 through 22, because, I can't type. But anyways, find the real zeros in your multiplicity. Real zeros are also known as x-intercepts. And multiplicity is pretty easy. If you cross the x-axis, multiplicity is 1. If you touch, multiplicity is 2. All right, so I have an x-intercept here at x equals -1. And it is bouncing off. It is touching. So its multiplicity is 1. All right, what else have I got? I got one here at 0. And it's another one of those where it bounces off. So its multiplicity is 2. And this was a 2 as well. You can tell I'm wiped out. And the last one I have here is I have an x equals 3. And that's crossing. So the multiplicity is 1. Degree and sign of the polynomial based on n behavior. Now this particular bad boy is starting high and ending low, which is going to be an x to the odd, specifically a negative x to the odd. Least degree of the polynomial based on turning point theorem. So what that says is x to the n is simply the turning points plus 1. Number of turning points you have, add 1. And there's a turning point there, there, there. That's 3. And there, 4. So x to the n is going to be, sorry, let me rewrite this. When we talk about x to the n is the TP plus 1. So I have 4 turning points. And I add 1, I get 5. This is at least x to the 5th. And if you just take your numbers up here, 2 plus 2 plus 1, by golly gee wow, it's 5 if you add them together. Your known factors, those come from your x-intercepts. So if you have an x-intercept at -1, you have an x plus 1. If you have an x-intercept at 0, you just have x. And if you have an x-intercept at 3, you have x minus 3. Now, factored form, where it gets a little tougher, you also have to talk about the multiplicity. This x happened twice, so x squared. This x plus 1 happened twice, x plus 1 squared. And x minus 3 happened once, x minus 3. And I forgot a letter of the alphabet. All of our forms start with the letter A. And that's my real goal here, is to figure out the factors at the end and also figure out what A is. And I can figure out what A is by taking that point 218 and plugging it in. 18 would be a times x is 2. Remember, I'm just substituting in y is 18, x is 2. 2 plus 1 squared, 2 minus 3. And I plug in. Boy, this is a hard skill for some kids. I don't know why. 2 squared is 4. I'm going to keep a 4 in my head. 2 plus 1 is 3. 3 squared is 9. 4 times 9 is 36. 2 minus 3 is negative 1. Negative 1 times 36 is negative 36. And then I'm just going to divide out that negative 36. And maybe the problem is that you don't know what 18 over 36 is. Bro, that's elementary school. You basic. Negative 1/2. So here's my form, and I used y, but it should probably be written f of x. F of x is negative 1/2. And we'll put an x squared, then x plus 1 squared, and then x minus 3. And the order of the factors does not matter. It really doesn't. But that negative 1/2 has to be out front. That's the big deal. And there's your homework. If I felt better, I'd probably do some more. But I'm going to lose my voice pretty soon, so not doing anymore.